Okay, hi guys, we'll be continuing on seeing more questions on molarity and molality. So let's continue. So the first question is that the density of 1.35 mol NaOH solution is 1.02 gram per cc. Okay, so you have to calculate the molarity. So molarity equals to mass, or rather weight, moles of NaOH upon mass of solvent into 1000. We are taking all mass of solvent in grams. Okay, so now we have to calculate the molarity. Molarity is nothing but again moles of NaOH upon volume of solution into 1000. I am taking it in milliliter. Okay, so mass of solution would be mass of solute plus mass of solvent. Okay, and obviously density of solution is already given, so from there we can calculate the volume, but we have to see the fact that we can write this as 1.35 moles of NaOH is present in 1000 gram of solvent. Okay, so now what we can say is that the mass of NaOH, molar mass is 23. You can actually calculate the mass of NaOH. Okay, so I'm just writing over it here that obviously 23 plus 16 plus 1, you can calculate the mass of NaOH. Okay, which would be 40. Okay, 40 multiplied by 1.35 would give us 54 grams of NaOH is actually present with 1000 gram of solvent. So we can write this as that the mass of solution would be 1054 grams. Hence volume of solution would be 1054 over density, which is 1.02. So from here volume is calculated. Now this calculated volume can be put into here, and n of NaOH we already know that it is 1.35. Hence molarity can be calculated. Okay, now let's say it's not a question, so let's say we have that to phrase a sentence that liquid solution contains, let's suppose, two solutes A and B. Okay, and obviously molarity of A would be moles of A upon volume of solution, let's suppose in liter only, and molarity of B is moles of B upon volume of solution, again in liter. Okay, and suppose A and B are non-reactive. Okay, so in a liquid solution, when A and B are non-reactive, we can directly say molarity of A and B as the following. Let's do a question. So suppose we have 10 liter acidic aqueous solution containing 36.5 grams HCl and 6.3 grams, or rather 63 and 6.3 grams HNO3. We know that the molar mass of HNO3 is 63, molar mass of HCl is 36.5. Okay, so what would be the molarity of HCl? Molarity of HCl is number of moles of HCl, which is a given mass, which is 36.5 grams, upon molar mass, which is 36.5, divided by 10 liters. This would be molarity of HCl, and molarity of HNO3 would be 6.3, which is the given mass. 63 is the molar mass of HNO3 upon 10, which is the volume of solution. From here and here you can calculate the molarity. Next question is, rather next star point is that molarity of resultant solution will when more than one solution or a mixed solution. Okay, so we have to calculate, we'll be talking on molarity of resultant solution when more than one solutions are mixed. Okay, suppose we have HCl aqueous as molarity M1, volume V1, and HNO3 aqueous with molarity M2 and volume V2. So solutes are non-reacting, suppose. So in this case molarity of HCl would be moles of HCl upon volume of HCl plus, rather, V1 plus V2. I'm not talking about volume of HCl solution here, directly write V1 plus V2. Similarly, molarity of HNO3 would be moles of HNO3 upon volume of mixed solution, which is V1 plus V2. Okay, so if V3 is the volume of water also mixed in the resultant solution, then so if V3, that is volume of water also mixed in the reaction, then molarity of HCl will come out to be N of HCl over V1 plus V2 plus V3. Similarly, molarity of HNO3 would be N of HNO3 over V1 plus V2 plus V3. Okay, so due to dilution, volume of solution increases and the molarity decreases. However, number of moles of solutes or mass of solutes remains constant. So just a note here that due to dilution, volume of solution increases and molarity decreases. However, number of moles of solute or mass of solute remains constant. Therefore, just to write it again, that moles of solute before dilution would be equal to moles of solute after dilution. Okay, so let's say if initial molarity is M1 and initial volume is V1, and after the addition of solvent, final volume becomes V2. Solvent addition, then obviously M1 V1 equals to M2 V2. This is the final solution, volume of solution and final volume. We are not adding V2 volume of solvent, we are adding the some solvent so that final volume becomes V2. Okay. And why is this the case? This is the number of moles in the first initial number of moles, and this is final number of moles. And as number of moles won't be changing, hence we can equate M1 V1 to M2 V2. So with this, we come to the end of this lecture. In the next lecture, we'll be seeing some more examples on the same concepts which discussed in this lecture. Okay. Till then, good luck and goodbye.